Alrighty, now we have two calculator problems that actually need the calculator. So the first one says, this is the position function, 2t minus 7, and then times e to the t, and that's hard to see, but that is a t right there. And they want to know at the instant when acceleration is 0, what is the velocity of the particle. So we're going to go to the graph screen here. Notice I still have my first and second derivatives coded into y2 and y3. I find it useful to have them there if I can. So now I'm going to plug in the position function here to get 2x minus 7, and remember I'm using x because the calculator won't take a t, and then times e raised to the x. And I actually do want to just see the acceleration function, so I'm going to turn off the position graph and notice that my acceleration graph is highlighted. And I know that I just need time greater than 0, so I'm going to go to my window and change my x-axis to 0, and I'll try it to 6. I had that in there from something else, and we'll just see if it works here. So I'm looking for when acceleration is 0, which is why my window is okay, being -2 to 2. And I see I've got 1 point here, and I'm guessing that's the only place because e to the t causes this increasing function. So when it finishes graphing, which I'm looking over here for it to finish, takes its time. All right, now I'm going to go to second calc 0, and I'm going to find the time when acceleration equals 0. So I need to left bound it, to bring in, there it is, left bounded. Now I'm going to right bound it and enter and guess. And I find that the time when acceleration is 0 to be 1.499999, which is effectively 1.5. Now I want to find the velocity of the particle at that time. So what I'm going to do is go back to my graph screen, and I'm going to turn on the graph of the velocity function by hitting enter when I hover over the equal sign, turn off the acceleration function, and I'm going to hit the graph key again. And this is going to show me just the graph of velocity. And I'm going to hit pause while it finishes graphing. Okay, so now since I know that the time I want is 1.499, I'm just going to go to trace, and I'm going to plug in to my x value 1.499. And that tells me that my velocity at that moment is approximately -8.96. And so my answer is C. Now we'll go to number 13, which is a mean value theorem problem. It says that we have a closed interval from 1 to 4, and they want to know the value where the instantaneous rate of change is equal to the average rate of change. So what I'd like to do is go back to my graph, my calculator, excuse me, and I'm going to type in the function given 9x squared, and I'm going to divide it by the entire denominator and making sure to put the denominator in parentheses. Oops. Struggling to type in my second term here. Okay, so x squared plus 2. And the reason, and I'm just going to leave this here. Now I'm going to go to the home screen, and I'm going to evaluate my function. This is my y1 function because I just put it in y1 on my graph screen. I'm going to evaluate that at 4 and then at 1. Remember to go to variables. I go to alpha, trace, and I want y1, and then I open parentheses and put in 4, close parentheses. So I know that the function evaluated at 4 is 8. Now I go back and I need to evaluate y1 at 1. And I get out 3. And then of course 4 minus 1 is 3. So my average rate of change is 5/3. Now I need to know when my derivative, my instantaneous rate of change, is equal to 5/3. So I'm going to go back to my y equals screen, and I'm going to turn off my position function so I don't see it. My velocity function is turned on, and if I look at these x values, these look just where I had my window last time. So let me look at the graph of the velocity function. And I need to know where this velocity function is equal to 5/3. So as I think about it, a better idea would have been to head on over to the graph screen and put in a y equals 5/3 So I have an intersection point. Ah, look, there are 2 intersection points. So they want to know just on the interval from 1 to 4, because this is x equals 1, this point here will not be within the interval. So I'm looking for this intersection point here. And to do that, I get second trace, and I find the intersection point, which is choice 5. There's my graph 1, my graph 2, and guess. And it tells me my intersection point is at 2.2187, which is effectively 2.22, so my answer choice is C.